new terms that you're hearing, probably for the first time, if I'm not mistaken. So you have, I think all of you are familiar with the word force, right? It's a physics term, force. It has a magnitude, it has a direction. So in physics, they call it force. They use force as their basic terms. In engineering and architecture, we use the term load, L-O-A-D, load. Okay, we use the term load. Now, load is somewhat similar to force, not necessarily 100%. Okay, so a load, by definition, when a force is exerted on a body, okay, when a force is exerted on a body, it is called a load. Okay, so this is the term that we are most commonly going to use from now on, for you guys also. Okay. So simple stress and simple strain. So we'll slowly go in details. But before that, 1 minute, just give me 1 minute. Okay, coming back to components of building, we'll just talk about some of the basic functions. Okay. So yeah, we've named a bunch of components of a structure of a building, right? Roof, beam, slab, and all of that. So let's say what are the functions? So a roof forms the topmost component of a building structure. It covers the top face of the building. Roof can be either flat or slope based on the location and weather condition and based on the construction also. Okay. And parapet. What are parapet? So parapet are short wall extended above the roof slab. Okay, it's like a railing but made of a brick cement. Okay, short wall extended above the roof slab. It can be considered as a railing, but railings are actually made of different material. Okay. And also railing can be inside the houses where parapet wall is only extended above the top floor. Okay, along the edges. Now the next component is lintel. Anyone can guess what is a lintel? Now lintels are constructed above wall opening like doors, windows. So just above your door and your window, lintels, what they call lintels, are used to be constructed. Okay, so these structures, these lintels are going to support the brick wall that is above your door and windows. Okay, so lintels are made up of reinforced cement concrete. So I don't have any quick picture that I can show you, so you can just go and later Google it yourself, and you will understand easily what lintel means. You might have already seen them also. Next is beams and your slabs. These are your horizontal members in a building. Okay, horizontal members in your building. These are known as beams and slabs. Now for a single-story house, your top slab is considered your roof. Okay. If you're going to make your roof with RCC. Okay, continue. Yeah, your beams and your slab, they are constructed with RCC, reinforced cement concrete. Okay, reinforced, meaning you're putting your steel rods in there also. Okay. Now, columns. Columns are your vertical member. Columns are your vertical members constructed above the ground level. Okay, constructed above the ground level. Now, there can be two types of column. One is structural column and the other is aesthetic column or architecture columns. Okay, so as the name suggests, these architectural columns are built to improve the building looks, the building aesthetics. Okay, while structural columns is playing a very important role, which is carrying the entire load of the building and transferring it to the ground, to the foundation. Okay, so that is the function of a column. Now walls. Walls are also your vertical members. So very most common type is brick wall, right? Made from concrete bricks or bricks or stones or concrete blocks, etc. Now wall is going to provide enclosure, is going to close your structure, enclosure, and is going to protect you against wind, sunshine, rain, etc. Okay. Now openings are provided in wall for ventilation. Ventilation, windows and doors. Those are provided. Now plinth beam. The next component of a structure is plinth beam. Now plinth beam is constructed as similarly to your regular beam, just that it is constructed on the ground level. Okay, it is constructed on the ground level. And then finally you have your foundation. So you all know what a foundation is. It's going to transfer the entire load of the building to the ground. Okay, and it's going to give solidity to your structures. Okay, so now moving on to simple stress and simple strain. I would very much like to have okay. So concept of deformable bodies. Concept of deformable bodies. So what do you understand by saying, what is the concept of a deformable body? What is a deformable body in general? So any object, anything that is that has the capability to change its shape when a load is going to act on it, it is known as deformable bodies in general. Okay, deformable bodies, any object that is going to change its shape when there is a load or a force that is acting on it, it's called deformable bodies. Okay. So is a building a deformable body? Is a building a deformable body? Yes, right. It is absolutely going to change its shape when there is a load acting on it. Might not necessarily be visible to the naked eye until it just collapses, right? So when it deforms, there are two important properties that we have to take a note of, which is we called it the elastic property and a plastic property, right? Might be very difficult to think that a building is elastic, but almost everything is elastic. It just has its limit, right? It just has its limit. So if it exceeds that limit, it's just going to break, right? So everything has an elastic limit. Everything has its plastic limit. Okay. So yeah, we'll be going into that detail in this unit also. Now coming to the topic, simple stress and simple strain. Okay, so when we say stress, it sounds something like it's psychological, right? It sounds something like psychological, like a mental health problem. But in engineering, in architecture, stress is a load that is acting on a body per unit area. Okay. Just say when a load is applied to a structural member, when you apply load on a structural member, on a beam, on columns or slab, when a load is applied to a structural member, it will induce internal forces within the member called stress. Okay. When you apply a load on a structure, it's going to induce an internal stresses, internal forces, which we call stress. Okay. Now we're going to be studying about different type of load conditions that happens in a structure. Okay, which will be later. Now, for example, you have a room. You put your wardrobes, you put your table, and all of that. That is some type of load that is being applied on that slab, on that floor. Okay. So a load applied to a structural member, it will induce internal forces within the member, which we call stress. Okay. And if that is computed or measured based on the area, cross-sectional area, they are termed as intensity of stress. Okay, so basic definition of stress: when a load is applied to a member per unit area, the load that is acting on a body per unit area is called stress. Okay. Now, if there is a stress on a member, on a structure member, it's going to tend to deform, right? Depending upon the amount, depending upon the intensity of that, depending upon how strong that stress is, that structural member is going to tend to deform. It's going to tend to change its shape, right? So let me just get into what is elastic and what is plastic. Can I get an answer from you guys? What do you understand when you say elastic? What do you understand when you say plastic?
Sir, elastic body regains original length after load is removed, but plastic body does not
Yes.
regain it.
Yes, good. Very good. So elastic. So all of these properties that we studied in physics, which seems very minuscule, right? When you say elastic, all you're thinking about is a rubber band or something, right? All of these properties is going to come into play when you're talking about buildings, when you're talking about structures. Okay, very important properties. And also a defining property that how safe your structure is, right? So elastic body, when you apply load and it change its shape, it's going to come back to its original position, original shape. Okay, and plastic, when you apply enough load, enough stress to that body, it's going to change its shape, but it's not going to come back to its original form. That is your plastic behavior. Okay, and beyond plastic behavior is usually your ultimate, in plastic region, in plastic behavior, you have your ultimate stress. Ultimate meaning the amount of load that your body can carry, that your structure can carry before failure. That is in your plastic region. Okay, so anything beyond that ultimate load, your structure is going to fail. Your structure is going to break. Okay, so very two important properties of a structure: elastic property and plastic property. Okay, so we've talked about simple stress. What is a stress? Okay, so what do you think, by definition alone, what is the formula for stress? Stress, load divided by area. That is your stress. Stress is denoted by the symbol sigma. Do you know what sigma looks like? All these symbols and all. I used to have a PDF of it. If you were in class, I would just write it on the board to show you, but this is one problem that we face of conducting online classes. Okay, anyway, okay, I will do it later. After class, I will go and look at the symbols, all the symbols PDF that I have, and I will share it to you if I find it. Okay. Or you have your phone also. Okay. If you want to know what it is right now, you can just Google it. Simple stress, okay, denoted by the symbol sigma. So the formula is load divided by area. Okay, this marker is not working. Okay, so load, it's basically a force. So what is the unit of load? Unit.
Newton.
Yes, the unit of load is Newton. 1 kilonewton equals how much Newton? 1 kilonewton equals how much Newton?
1000 Newton.
Yes, 1000 Newton equals 1 kilonewton. Okay. And what is the unit of area, sectional area?
In SI, it's meter square.
SI.
In SI, it's meter square.
Yes, meter square. But you're going to use millimeter. I'm going to use millimeter. Okay. So mm square. So what do you think is the unit of stress?
Newton per millimeter square.
Newton per mm square. Okay, so that is the unit of stress, Newton per mm square. Okay. And also sometimes it is written as megapascal. Okay, 1 Newton per mm square equals 1 megapascal, MPa. Okay, MPa, M stands for mega, Pa stands for Pascal. Okay. So that is your simple stress. Load per unit area is your stress. And you have the formula, you have the unit. That's pretty much all there is to know. Now the next one is simple strain. Simple strain. Stress and strain. So if a body is subjected to a load, then it's going to tend to change its shape, right? It's either going to elongate or it's going to shrink, depending upon the direction of load that is being applied, right? So that change in shape is known as your simple strain. Okay. A body is going to change its shape either in length, either in volume, or either in shear. We'll come to that. So that change in shape is known as your simple strain. Shape and size. It's all about strain. Okay. Now, how do you measure strain? By definition, is a change in shape, but how do you measure it? So if, let's say, you have a bar, and you have two machines pulling in the opposite direction, and that bar is going to elongate. The size, the length of the bar is going to increase. Okay, we only talk about lengthwise at the moment. So so how do you measure strains? Strain equals change in length, denoted by delta L, change in length divided by original length. That is your simple strain. Okay, how do you measure strain? Change in length divided by original length. Now strain is denoted by epsilon. Okay, by the symbol epsilon. Strain is denoted by epsilon.
Excuse me, sir.
Yes.
So, is there any way that you can show us like written work or like some blackboard of some kind? Because it's very confusing to just listen to it and actually work it through.
Yes, yes. So I'm going to talk about simple stress, different type of stress and different type of strain. And I have a working marker here. I'm going to have to hold the camera and face the board. Okay, so just one moment. Okay, so anyway, we have defined stress. It's simple to understand, right? What is stress? What is strain? Strain, basically a change in shape. Stress, when you apply load to a body per unit area, it's called stress. Right? So now it's time to talk about different type of stress and different type of strain. So stress, So one term, we called it compression. We called it tension. Another one is bending. And the other one is shear. Okay, so you have 4 types of okay. 1 minute. Is the video clear for everyone?
Yes, sir.
Okay. Okay, now simple stress, different type of stress. The first one is compressive stress, compression. Compressive stress. So what do you mean by the word compress? You're pushing in your object, right? You're pushing it. Compress, right?